taking a look at your opener for 9.2. So yes, chapter 9 we do group in with chapter 4 just because we deal with the transformation still. All right, so we're going to do 4 sections of chapter 9 here. When we do them, you're going to see a little bit of a different spin on them, and then I'm going to leave it up to you how you want to work with them. Okay? And we'll talk about exactly what I meant by that in a little bit. In your opener, it says triangle ABC has your vertices that are given there. It says translate that figure left 3 units and up 2 units to find its image. So if I take point A, if we go left 3, then we are taking that x value and we are subtracting 3. If we go up 2 units, we are taking that y value and we are adding 2. So for A prime, we're going to end up at negative 5, 3. For B prime, we're going to end up at 0, 0. And at C prime, we're going to end up at 2, 5. Right, so just shifting those around using those translations. Now, another way we're going to be able to do these translations and all of our different transformations is going to be in what they call a matrix. What a matrix actually is, it is a rectangular arrangement of numbers in rows and columns. So here you will see there are 3 rows, row 1, row 2, and row 3, and there are 2 columns, column 1 and column 2. Those dimensions, they tell me how many rows and columns there are. So in this case, I have 3 rows, row 1, row 2, row 3. We have 2 columns, column 1 and column 2. It is always written as rows by columns. So you will see that this is a 3 by 2 matrix. Inside that matrix, there are 6 values. Each of those values is what they call an element. Oops. Sorry about that. There we go. Each number inside is an element inside your matrix. Now, what we're going to learn to do today is take our points and put them in that matrix form. If I have a point that is 3, negative 4, for example, to put it in a matrix, we're actually going to flip it around on us. We're going to put it in as 3 on top and then negative 4 on the bottom. So the x always goes on top, the y goes on the bottom. So if we look at my quadrilateral, point A is out here at negative 3, 0. So point A is going to have a negative 3 on top and a 0 on the bottom. If I wanted to extend it out to a quadrilateral, all we're going to do is each of our points has its own column. So it's negative 3, 0 for A. B is up here at 0, 3. C is over here at 2, 1. And D is down here at negative 1, negative 1. So if we wanted to do that for triangle RST, our X's go on the top, and our Y's go on the bottom. Now, there are different operations you can do with your matrices. You can add them, you can subtract them, we can multiply them. And they have different rules depending on what you want to do. Adding and subtracting have one set of rules. To add or subtract your matrices, your dimensions must be the same. So if I have a 2 by 2 matrix, it can only be added with another 2 by 2 matrix. And your answer will likewise be a 2 by 2 matrix. If you have a 2 by 3 matrix, you can only subtract a 2 by 3 matrix from it. And then your answer will be a 2 by 3 matrix as well. Because to add or subtract matrices, all you are going to do is add and subtract those corresponding places. So we are going to take our 4 plus 1 gives us our 5. Our negative 2 plus 2 gives us 0. 2 plus 5 gives us 7. Negative 3 plus a negative 6 gives us a negative 9. Same thing on the bottom then. 7 minus 3 gives us 4. 4 minus negative 6 gives us 10. 5 minus 5 gives us 0. Doing the bottom, 1 minus 0 is 1. Negative 2 minus 7 is negative 9. 8 minus 1 is 7. So that's how you add and subtract matrices. Now, a translation is truly just adding a matrix to something that's already there. If I wanted to take this matrix here, 4 units left and 1 unit down, we have your polygon matrix, which they already gave us. If I want to go 4 units left, I need to subtract subtract 4 from all of my x's. If I need to go 1 unit down, I need to subtract 1 for all my y's. However, when you do these operations, instead of adding or subtracting, it is always going to be an addition problem. You're never going to have subtraction. Instead, you will take care of the sign inside your matrix. So if I need to move it 4 units to the left, I'm going to add a negative 4 to my x. If I am moving 1 unit down, I'm going to add a negative 1 to my y's. And remember, your matrices need to have the same dimensions. So if I have a 2 by 3 matrix, my translation matrix must also be a 2 by 3 matrix. And then we just add those values together to get our image matrix that's there. If we plot our points, there's what we get. Now, multiplying instead is a little bit more difficult. To multiply, first off, our process changes. Our rules change. In order to multiply, the columns from the first matrix must match the rows from a second, which means a 2 by 2 matrix, the columns from your first would have to be a 2 by something matrix, must match the rows from your second. So these two inside numbers have to match up. A 2 by 4 matrix, for example, could only be multiplied with a 4 by something. Or a something by 3 matrix would have to be multiplied with a 3 by something matrix. These inside numbers have to match. That's what our rules say. The columns from your first must match the rows from the second. Your outside numbers, though, they are not useless. They tell us how big our answer should be. So when you multiply matrices, what I'm going to have you do is make what they call a skeleton matrix. My answer came from these outside values. It's going to have 2 rows and 2 columns. The way you multiply matrices, unfortunately, it is not just going to be straight through like we did with adding and subtracting. When you multiply, you must take a row from your first matrix times a column from your second matrix. So what we mean by that, this is row 1, column 1. This is row 1, column 2. This is row 2, column 1. This is row 2, column 2. And that tells you what pieces you need to multiply. Let's start in the top left. I need to take row 1 times column 1. I have 2 values times 2 values. We do the first times the first, and we get 0. We do the second times the second, and we get a positive 32. So we have 0 plus 32, which is 32 for the top left. Take a look at our next one. We'll go to the top right. That is row 1 times column 2 now. Once again, we have 2 values times 2 values. I do the first times the first, which is 0. I do the second times the second. That's a negative 12, so it's 0 minus 12, which is negative 12. Go to the bottom. We have row 2 times column 1. Once again, we're going to do the first times the first. That's 5 and negative 4. That's a negative 20. And then we do the second times the second. That is a positive 16. So there's negative 20 plus 16 is negative 4. Then for our last one, now we have row 2 times column 2. First times the first. 5 times 1 is 5. Second times the second. 2 times negative 3 is negative 6. So we get a negative 1 when you add those or subtract those values. This is your answer then. Notice it's a little more complicated than just adding or subtracting. Take a look at your next problem then. If you want to pause the video and do it on your own, go ahead and try it. So we have a 2 by 2 and a 2 by 2. We are allowed to multiply them because these numbers have to match up. Our answer comes from the outside. Our answer is going to be a 2 by 2 matrix as well. So I'm going to make my skeleton matrix 2 rows, 2 columns. I do my first row times my first column. First times the first is 6. Second times the second is a 0. So I got 6 plus 0. Now we're going to do the first row times the second column. First times the first is 0. Second times the second is negative 3. So 0 minus 3 is negative 3. Go to the next spot. We'll do the second row times the first column. First value times first value is 2. Second times the second is a minus 0, or plus 0, depending on what you want to put. 2 minus 0 is 2. Last one, second row, second column. 2 times 0 is 0. Negative 1 times negative 1 is a positive 1. 0 plus 1 gives me 1 then. So there's your answer then to multiply. In your next one, just subtracting those values. Once again, you can pause the video if you want to try it on your own. I have a 2 by 2 minus a 2 by 2. So we will get a 2 by 2. Just subtract your values. 3 minus 9, negative 6. Negative 5 minus 7, negative 12. 8 minus negative 3 is 11. -4 minus 1 is 3. So there's your answer. Notice adding and subtracting is a lot more straightforward. Right, next one has you doing those matrix multiplication or matrix addition or subtraction to translate your figure. 3 units right and 2 units up. So we're going to use our translation matrix. It says you're going to add 3 to all the tops, add 2 to all the bottoms. Remember, this is always a plus sign. And then you take care of up, down, left, right with the sign inside your translation matrix. 3 units right is all positive 3s. 2 units up, it's all positive 2s. Your polygon matrix was given to you. So your image matrix, then we just add 3 to all of the tops, add 2 to all the bottoms. If you were to plot them, there's what they look like. Last problem then. It says a men's hockey team needs 7 sticks, 30 pucks, and 4 helmets. A women's team needs 5 sticks, 25 pucks, and 5 helmets. Then they give us the cost for those sticks, pucks, and helmets. It says use matrix multiplication to find the total cost for each team. If I wanted to find the total cost, right, if I was just looking at it to set up an equation, we would take the items times the price, and it will give us the total cost. Well, our items need to be organized. In this problem, they have 2 different sets of information. So I'm going to set it up just as we see it there. 7 sticks, 30 pucks, 4 helmets. That was for the men's team on top. I'll put the women's team on the bottom then. 5 sticks, 25 pucks, and 5 helmets. Right now we have a 2 by 3 matrix. That means my price matrix will have to be a 3 by something. Oops. 3 by something. Well, my prices, I can just make it a 3 by 1. I can go 30, and then 4, and then 50, because those are the only prices I needed. So we're going to make it a 3 by 1 matrix. Notice now we are allowed to multiply them because those middle numbers match up. The outside numbers here, they tell us how big my answer will be. It will have 2 rows and 1 column. So we are going to take row 1. If I look at my positions, this is row 1, column 1. This one down here is row 2, column 1. There's only 1 column in this whole thing. So take your top one, row 1 times column 1. We have the first value, 7, times the first value, 30. So that's 210. Second value is 30. Second value is 4. 30 times 4 is positive 120. Third value is 4. Third value is 50. I get a positive 200. Add those all together. We get 530. Let's do the bottom one now. Row 2. Times column 1. Once again, we'll do first value times first value. That's 5 times 30 is 150. Second value times second value, 25 times 4 is a positive 100. Third value times third value, 5 times 50 is a positive 250. Add them all together. and we get 500. What that tells me is my men's team was $530. My women's team was $500. Now, one quick thing to talk about on your homework tonight. You're going to see problems where they ask you about your commutative property or the associative property. Remember, commutative property is just going to flip the order of these. So if I were to multiply my two matrices together, here I would be doing 1 and 2 times a -1 and a -4. First times the first is -1. Second times the second is a -8. -1 and -8 gives me a -9. If we come down to the other one, if I flip the order of it, I'd be doing -1 and 2 times a 1 and a 3. I get a -1 and a +6. That gives me a +5. These values are not the same. I'm not allowed to just change the order of my two matrices. Matrix A times matrix B is not going to be the same as if I do matrix B times matrix A. Right? They're going to give me different values there. And then here's your homework.